Welcome to the fourth video of the IoT in Practice workshop series. In the previous episodes, we installed the operating system on the Raspberry Pi and configured the MQTT broker. Today we are adding a server with a database. Let's get started. First, let's create a directory called server to store our server files and navigate into it. Next, we will add the Node.js repository and install it. This might take a few seconds. Now initialize the project inside the server directory and add the MQTT library to it. Create a file named server.js. While it's usually better to write code in VS Code on your machine, which I will show you later in the video, for this simple version of the server, a basic editor like Nano or Vim will do just fine. We import the MQTT library, create a client, and provide the username and password. When the client connects to the broker, the server will log connected with MQTT broker, subscribes specially to the test topic, and publish the message "Hello from Node.js app" to that topic. Whenever a message arrives on the subscribed topic, it will display that message. In a new terminal window, let's subscribe to the test topic and start the server using the command node followed by the file name server.js. We can see the server connected and send the message to the broker. Now let's open another terminal and send a new message. But what happens if we send a message to a topic other than test? Let's find out. Let's change the subscribed topic to hash, which means we are subscribing to all topics. So the server is only listening to test, while our terminal client is listening to everything. Let's send a message to the topic test2 and hit enter. As you can see, the server didn't receive the message because it isn't subscribed to that topic. Remember, we are building an IoT system, so it would be good to store the incoming data somewhere. So let's install the Postgres database using the command sudo apt install PostgreSQL. Let's log in as the Postgres user, launch the database client, and add a username user1, for example. Now let's create the database where we will store messages from our system. We can now log out of the Postgres account and connect to the database as user1. Let's create a table called MQTT test messages that will consist of an ID, the topic, the message, and the timestamp when the message was received. If you are wondering how professionals create electronics without chaos and with maximum collaboration, the answer is Altium Develop. Imagine an environment where you eliminate the problem of manually emailing files to others, such as mechanical engineer for PCB verification, and start working in real time in one cloud. Altium Develop is an advanced professional central hub that integrates the PCB design tool with the broader ecosystem. With it, you can forget about the frustration and delays that come from constantly losing context and having to manually track corrections. Great, now we just need to update the server code. Editing files in Nano can be a bit clunky, so you might want to copy the code and open it in Visual Studio Code. We add the database client, connect to the database and configure it so that when a message is received, it gets saved to the database. Now, the easiest way is to delete the old server.js file, create a new one, and paste in the updated code from VS Code. Let's run the server and send a few test messages. We can see that the data was successfully saved to the database. Let's verify that. Open PSQL with the database name and list all records sorted by the time they were received.